Hey, welcome back. We're going to do Chapter 2, Statistics. My name's Todd McLeod. I'm your instructor in this course. I'm going through the book. I hope you're going through the book. Like, I read the chapter. So I know exactly what you all are looking at. And it's important, two important things just at the start here. The first thing, it's important to tune into these videos because right at the very front, often I'll tell you if there's something important which is on my mind or which you should know about, which could help you do better in the class. I'm just making sure I'm recording. And so the first thing, two important things. The first thing is like this book goes into Microsoft Excel. It does some Excel stuff. You should totally know Microsoft Excel. I've mentioned this elsewhere in the class. You should know how to use spreadsheets like Microsoft Excel or Google Sheets. But this is not a Microsoft Excel course. And you should take a Microsoft Excel course. It's super important to know how to use that software, know how to use spreadsheets. So occasionally we'll do stuff with spreadsheets, but when you come to the stuff in the textbook that is specifically about Microsoft Excel, I'm just skipping that stuff. I'm skipping it. I'll go over a little bit of it in this chapter if there's stuff that I think is important, but when I'm reading the textbook, I'm not reading through the Microsoft Excel stuff. So I'm not doing it, and I'm giving you permission to not do it. It's not something that I'm emphasizing in this course. So we're emphasizing statistics, not spreadsheets. That said, I will personally teach you some stuff about spreadsheets, but when you're reading the textbook and you come to the stuff about spreadsheets, about Microsoft Excel is a spreadsheet. When you come to that in the textbook, just go ahead and skip it. The next thing is that you should heavily be leaning on ChatGPT. So if you watch the previous lecture, and in the previous lecture, let's just go into one of the DS23 classes, and we'll go into modules. And if you come down to modules, here we have this one here where I'm doing the assignment. If you watch that, I was heavily leaning on ChatGPT to help me do some of those assignments. So I really encourage you to watch all these videos, at least check them out. You can watch them on 1.5x speed or 2x speed. And also the second main point. First main point, skip over Microsoft Excel stuff in the textbook. Second main point is heavily lean on ChatGPT. So here's ChatGPT when you're doing your stuff, when you're learning about statistics. It'll help you learn everything. It's like a super smart tutor. You have to pay to use it. For the better version, the free version is kind of mediocre. But if you pay 20 bucks a month, you get a great version. It'll be the best tutor you've ever had for any subject you're learning about. You could upload files. You could take pictures. You could have conversations with it. It's fantastic. So that's the second main point. First main point, skip the stuff on Microsoft Excel in the textbook. That's the first main point. Second main point, lean on ChatGPT. All right, that said, let's get started going into Chapter 2 and learning about statistics in Chapter 2. And what Chapter 2 is all about, I'm just grabbing my water and bringing it closer. Chapter 2 is about descriptive statistics. So descriptive statistics is finding ways to describe the statistics that we come up with as statisticians, and how do we more effectively describe the statistics we have come up with. That's my definition of descriptive statistics, but here we're going to go to ChatGPT, and we'll say, can you please explain for me? Can you please explain descriptive statistics for me? And we have two responses. Sometimes ChatGPT will give you two responses, and that's how ChatGPT improves. It's asking you, right, like which do you think is the better response? And based upon that, it's learning how to deliver better answers. So if you occasionally choose your preferred response, look at each of them and choose the one which you like best, and that's helping make ChatGPT better. And so these are still generating. We'll let them generate for a moment. And now let's compare them. So we'll read the opening paragraphs. Descriptive statistics is a branch of statistics that focuses on summarizing and describing the main features of a collection of data. Unlike inferential statistics, so inferential statistics is when we have an entire population, let's say all of the citizens of America, and then we just take a sample of that, let's say like 3,000 people, and from that sample we make inferences about the population. We study the sample right? And we don't study the whole population, we just study a sample. And when we get that information about the sample, we make inferences about the population. That's inferential statistics. So inferential statistics aims to draw conclusions about a population based upon a sample. Descriptive statistics simply provides a way to present data in a meaningful way, allowing patterns to emerge. So presenting data in a meaningful way, allowing patterns to emerge. And so here we have a slightly different version paragraph. Descriptive statistics is a branch of stats that involves summarizing and organizing data so that it can be easily understood. Unlike inferential statistics, which seeks to make predictions or inferences about a population based on a sample, descriptive statistics simply describes the data that is immediately at hand. I'm liking response 2 better, but let's continue looking at them. Key concepts in descriptive statistics. There's a lot of S's in the word statistics. There's the mean, there's the median, there's the mode, the arithmetic average of a set of numbers. It's calculated by adding all the values together and dividing by the number of values. The sum of all data points divided by the... So I'm liking this response better already. I'm just going to go with that one. And so now we just have this. So here you could read, right, measures of central tendency, mean, median, mode. We're going to learn about these coming up, I think, in the next chapter. But the mean is just another word for average. So those are synonyms. They're pretty much the exact same meaning, 2 different words with the exact same meaning, mean and average. So you could say mean, you could say average, same thing, right? And then we're going to look at the median, which is the middle value. But these are all measures of central tendency. And so this is a really important concept. And here I'm going to illustrate this. So I'm going to go into spreadsheets, and I'm going to create a new folder here. And this new folder is going to be 02. And then I'm going to need some data in this folder. So I'm going to look to see what kind of data I have here in the first folder. And I think I'm just going to make up some data. So I'm going to go back here and go back into 02. I'm going to go to new up here, and I'm in Google Drive. So Google Drive, and I'm going to do new sheet right here. I'm going to create and I'm going to share, and I'm going to create some data. So sales, so we'll call this one John, and we'll call this one, I don't know, Robert. And these are salespeople, and I'm going to make this bigger. And so I'll make it 200, and then we'll give it some data. And so here we have 8, 10, 8, 12, and then we have 10, and that is like what, 32, 40, 48. And we're going to go with, I want to get up to like 50, but that's at 48. So we'll make this one 12 also. So there we go. So now we got 50. If I add those up, and I could add them up by doing the equal sign, all formulas in a spreadsheet start with equals, and I could click on each of these and then put in the operator between each of the cell references. So this is adding up the contents, the value in cell A2, column A, row 2 is right here, that's A2. Here's A3, that's A3, so it's adding up the value in A2, A3, A4, A5, and A6, and that's going to give me 50. So my average, I'm going to right click up here, and I'm going to choose insert one column left. My average is right, or this is my total, right? My average is going to be that total. It's going to be that total, so equals to B7 divided by 5, because there's 5, 1, 2, 3, 4, 5 data points. So that's going to give me 10 is my average, and that is also known as your mean. So average or mean, right? You could call it either one, and those are exactly the same thing. And then if we had another one here, and let's say we had like, I don't know, we had 80. And we had like, you know, 5, and then we had, well, we got to do like here 30, and then we had 5, and then we had here, we had 10, and we had 2, and then we had, so that's 47, and we had 3. And then when I add all these up, and so here's a cool thing I could do. I'm going to go into formula view, which is with my control backtick. And that shows me my formulas. So there are my formulas. And when I copy this, Control C, and then come over here, and I'm going to paste it right here. And when I paste it, these are relative references. So it went from B2, 3, 4, 5, 6 to C2, 3, 4, 5, 6. And so that's the way formulas work in a spreadsheet. It's called a relative reference. So this is referencing B2. This is referencing B3. So where this formula is relative to where it is, it's adding up the 5 cells right above it. So relative to this formula, it adds up the 5 cells right above it. And if I move this formula here, it's going to add up the 5 cells right above it. Those are relative references. If I put dollar signs in front of the references, it makes the reference absolute. So now if I do a Control C, come over here, delete that one, and do a Control V there, all of the first 4 references were relative, but this last one was an absolute reference. So relative to where this formula is, always absolutely reference B6 right here, right? This is just for an example. And but the rest of these references were relative. If I take the absolute reference off of this reference right here and just have it be B6 again, delete that once more, do a Control C and a Control V, they're back to being relative references. If I go out of formula view, so here if we go to view and we have show formula guidelines, formulas right here, you can see the shortcut key, Control backtick. So if I go take that off and I want to show formulas, it shows me the results. You can see here, right, like you can see here that they both calculated 50 for the average, or for the total. And then the average, same thing here. If I copy this over, so go back into formula view, and let me make this a little bit bigger so we could see it all the way. I guess I'll just leave it like that, so we always see these. I now copy this one over, Control C, Control V, it's going to be C7 divided by 5 because it's a relative reference, right? It's referencing the cell right above it. Relative to where this formula is, reference the cell right above it. Relative to where this formula is, reference the cell right above it, and then divide by 5. So when I move it from here to here, it references the cell right above it, relative to where it's at, and divides by 5. That's a relative reference. That's just the way spreadsheets work. Someone decided that should be how they work. So that's your total. And then that's your average or your mean. And then just thinking about, and this is a measure of central tendency. So we have all this data. These are our data points. We'll just give them some slightly different colors. So we'll do this one like yellow, and we'll do this one like, I don't know, we'll do like a light blue. Those are our data points, right? And then, you know, all these data points, the measure of central tendency, so that's what we're talking about here. Measure of central tendency, the mean, the average, right? The measure of central tendency, the mean is 10. So that's kind of saying, you know, even though this data has a few points around that, it's that's the central tendency. I like to think of a bullseye. Like if I was at the shooting range and I'm shooting a bullseye target, or maybe it's bow and arrow and I'm shooting my arrows at the bullseye target, I'm not always going to hit the bullseye. My arrows are going to hit around it, right? But the central tendency is that, you know, if I looked at like the dispersion of all the places my arrows hit, there'll be a central place. It's just kind of like, you know, the central point of all of those groupings. That's the measure of central tendency, right? You know, like they all kind of hit around the bullseye, and then this is the central area that they were all sort of between all the places they hit. That's the area that's central to all the places they hit. So just thinking about that, measure of central tendency here. If these are salespeople, on average over 5 days, the total that they sold over 5 days is 50, and on average each day, that's 10 a day. But as a salesperson, this person is much more consistent. They're between 8 and 12 sales a day. This person has really hot days and really off days, right? So this person's less consistent. So this person has more variability, more variance. The data here varies more. It varies more around this measure of central tendency, around the mean. The data varies more here for Robert than for John. So not only do we look at measures of central tendency, right? Like what's, you know, with all the different places the arrow hit, what's the central point of all those different places they hit, right? Not only do we look at measures of central tendency, but we're also going to look at how much does that data vary around that center point. So the data here doesn't vary as much as the data here varies a lot more around that central point, because variance is also important. So if these were suppliers, right, if they were supplying things to me, and this was the number of days it took to get supplies once I placed an order, like John is going to be much more consistent. I know that when I order from John, I'm getting stuff in like 8 to 12 days consistently. It doesn't vary that much. But if I order things from Robert, again, now we're switching here that these guys are shipping me stuff when I order things. If I order stuff from Robert, man, sometimes the stuff gets here really quick and sometimes it takes an entire month. The data varies a lot around this measure of central tendency, the mean. And so that's a super important concept in statistics, having this idea of like, what's the central point of all these data points? Where's the central point? What's the measure of central tendency? What's the mean? And then also, how much does the data vary around the mean? How much does the data vary around that central point of tendency? And so there's other measures of central tendency that we'll get into. There's the median, there's the mode. You could read about those. Then here's the measures of dispersion or variance, right? The range, the variance, the standard deviation. We're going to learn about those. And then there's measures of position, percentiles, quartiles, interquartile range. We're going to learn about those, right? And how's the data distributed? Frequency, distribution, skewness. We're going to learn about those. And then visualizing statistics, right? Descriptive statistics, charts, graphs, histograms, blocks, plots, pie charts, stem and leaf diagrams, scatter plots. We're going to learn about all those. How do we better visually represent our data and describe our data? But a really important concept in statistics is a measure of central tendency, right? Like the average or the mean. And then how much is the data dispersed, or how much does it vary around that measure of central tendency, the mean, right? And so that right there is an important concept in statistics. All right, so descriptive statistics, we got a little description of descriptive statistics. And just to refresh our memory, it's a branch of statistics that involves summarizing and organizing data so that it can be easily understood. And you know, inferential statistics is looking at what the data and insights we get from a sample and making inferences based upon that sample, making inferences on the population. So, you know, it's pretty much exactly self-explanatory. Descriptive statistics, how do we describe the statistics? Inferential statistics, what inferences can we make about a population based upon a sample that we studied from that population? Okay? Pretty cool, right? All right, I'm going to pause the video for a second and take a drink of water. Cool, here we go. We're recording again, and I'm just watching this to make sure it's ticking up, and we got volume. All right, so now we're going to, you know, when we look at descriptive statistics, we're going to summarize data for categorical variables and for quantitative variables. I like calling these qualitative because qualitative, you know, because qualitative has more assonance with quantitative. So we're going to summarize data for qualitative variables, right? And qualitative, we'll put that in here again. Qualitative data uses labels or names to identify categories of like items. And quantitative data are numerical values that indicate how much or how many. And I put down here as a little note this information here, and I'll just make this bigger. And I'll copy it, and then I'll come up here and I'll just add this in here as a little bit of a reminder. And there it is. And then we'll make this larger, make it like 20. Here, we'll just grab that right there. There we go. So remember our acronym, nominal, ordinal, interval, ratio, NOIR. And then we have alphabetic, qualitative, categorical is nominal and ordinal. And numeric is, and quantitative is interval and ratio. Right, so those capital lettered words there are nominal, ordinal, interval, ratio. And nominal and ordinal is usually alphabetic, and it's qualitative, which is also known as categorical. And then interval and ratio is numeric, and it's quantitative. And again, remember, nominal is like the name, ordinal is like nominal, except there's some ranking to it, like A, B, C, D, right? That's alphabetic, it's qualitative, it's categorical, A, B, C, and there's an order to it, there's a rank to it. Like in a class, an A is a higher grade than an F, right? So nominal is just a name, and a name would be like the name of a country, or, you know, or like, you know, you are, I don't know, I'm trying to think about things without an order or without a rank to them. You are living on the left side of the street or the right, left or right. It's a category, it's qualitative, but there's no better or worse. You're on the left side or you're the right side in this scenario. So, but ordinal will have a rank, and then an interval is that the space between a numeric value has an interval. There's an interval between it, and then that matters, and that gives us some insight. Let me just think of some score. Yeah, I guess like an SAT score. I'm not totally positive about that, but like 90% certainty, like 800 is better, or credit score, an 800 is better than a 600. There's an interval, but you can't really say an 800 is like 25% better. So new minus old, 800 minus 600 is 200 divided by 600, 33% better, right? So you can't really say an 800 is 33% better than a 600, because we don't really know if that's the case with how credit scores are calculated. So it's just an interval, but you can say that 800 is better than 600. And then ratio has a zero value. That's the important part about ratio. Height, weight, right? Speed. So those are all distance traveled, right? Those are all ratio. So those are numeric and quantitative. So just a little bit of a review there. So we're going to look at summarizing data for categorical variables. And when we summarize data with categorical variables, we have frequency distribution, relative frequency distribution, percent frequency distribution, bar chart, and pie chart. So we're going to learn what all these are. Some of them you might already be familiar with. So here's a frequency distribution. So let's say we had all this data here and we measured, hey, what kind of soda are you drinking? And we sampled 20 purchasers. And this is the data that they came up with. So we have 1, 2, 3, 4, 5, 6, 7, 14, 20. And we could take all this and create a frequency distribution. We could see how many people were drinking Coca-Cola. So there's 2 people on this list, Coca-Cola here, Coca-Cola there. That's a frequency distribution, right? 2 people had Coca-Cola, 3 people had Diet Coke, 5 people had Dr. Pepper, 9 people had Pepsi, and 1 person had Sprite. So it's a tabular summary of data showing the number, frequency of observations in each of several non-overlapping categories or classes. The objective is to provide insights about the data that cannot be quickly obtained by looking only at the original data. Here's the original data. Okay, and then this gives us more insight. It's more descriptive, right? Descriptive statistics, it's more descriptive. So that's a frequency distribution. It's kind of a convoluted, complicated sounding phrase, but when it's also self-explanatory when you think about it. What is the frequency with which there are people who purchase Coca-Cola? What was the frequency of Diet Coke showing up in our sample, right? 3. So that's a frequency distribution, and then, again, there's just that same picture. And we could use Microsoft Excel. So here's a little spreadsheet. We could use Excel to look at our data and then to figure out, to count it up. And we're using the COUNTIF function here. And you're saying with absolute reference to, we're holding the number 2 constant, but we're not holding a constant. I would have made a and 2 constant, right? But since this is only dropping vertically, you don't need to do that. But the $sign means this is an absolute reference to 2 right here. And so it's A2, and this is an absolute reference to A2 through A21. So we're always referencing all of these. We're saying count all of the references between A2 and A21 from here all the way down to 21. Count all those references. And what are you counting? How often does Coca-Cola show up in this list right here? How often does Coca-Cola show up? Here it's C3, there's C3, C3. How often does, this is Diet Coke, how often does Diet Coke show up in this list right here? And that list is from A2 all the way down to A21. So it's looking through that list for Diet Coke, and it's counting if Diet Coke is in this list, and it's getting the Diet Coke from right there. So it does all those, and it counts them up, and then it sums it. But that's just a little insight into how a spreadsheet would work. If you want to see that in action, let me see if I could copy these here. So I'm just going to copy all these data references and see if I get all of them. Start down here. And I'm just going to do a Control-C. And we'll go back to my spreadsheet, and we'll put in a new reference, and we'll do a Control-Shift-V. And we pasted all those down. I'm going to right-click here and do Insert Row Above. And then what do we want? We want to have in our frequency distribution, we want to have soft drink, selection, customer selection. We'll call this customer selection. So we surveyed 20 people, right? And we could do one more right click here, insert column to the left. And so this is the first person we surveyed, the second. And we could autofill that by grabbing this autofill handle and dragging that down. And so that's customer selection. And we'll make this bold. We'll make this whole row bold. And there's the customer selection. And then we want to find out, right, which of these did they drink. So I'm going to highlight those and Control C, and then come back over here and paste those in. And then the count for each of those. And so what did they call it? They call it frequency. We'll call it frequency because that lines up with what we're learning here. Frequency. And so I'm going to do in here a formula. I'm going to do a count if. And I could click this and it says, what's my range? I want my range to be this. And then as I move this formula down, I want my references to that range to always stay absolute. So I'm going to put $signs in on that. So I'm going to make that absolute. And I'm going to make that absolute. I got to see what's going on. Okay, so those are both absolute. Now I'm going to put a comma in. And now it's asking me for the criterion. And my criterion is like, does Coca-Cola count how many times Coca-Cola shows up in this list? So count it if the item in the list is Coca-Cola. So I'm going to press in my parenthesis. And now I'm going to press enter. And it has 2. And it's suggesting an autofill. I'm going to cancel that. Now I'm just going to copy this. And I'm going to make this wider. And I'm going to go into formula view, and I'm going to do a Control C, and I'm going to copy that all the way here. And you'll see it went C2, 3, 4, 5, 6, because each time I move this down relative to where this is, reference the cell just to the left. Relative to where this is, reference the cell just to the left. Relative to where this is, reference the cell just to the left. So this last reference in the function is the one to look up. And where is it looking it up? It's looking it up in this B2 through B21. B2 through B21. And that's your lookup kind of table. And that is always held absolute. That reference is always absolute. So regardless of where I put this function, this formula, right, it's always absolutely referencing B2 through B21 for the first argument in this function, which the first argument in this function is the lookup table. And then when I look at that, it created that frequency distribution for me. It shows me how many times each of those items occurred. Kind of cool. Kind of cool. Gotta admit, man, that's pretty cool. And if I wanted to, I could total those up. So to total those up, I could just come here and I could click on the formula icon, do sum, and I want to sum up all of this. And it's saying D2 through D6, D2 through D6, right? That's what I want to sum up, and that'll give me 20. Rock and roll. Like working more efficiently, working more effectively, working smarter. Relative frequency distribution. I'm just going to make sure I'm still recording. Sometimes my computer chops out. I'm going to stop this video here and we'll resume in the next video just because I'm a little bit paranoid my computer might crash. And we'll just put up a couple of videos here. So this will be the end of the first one. We'll pick up in the next one, relative frequency distribution.